So in the second decision report, you're answering the question of just what is the largest price that we could conceivably charge for our product and still sell anything, and also what's the largest amount of quantity that we can expect to sell in the national market to sell at any reasonable price. And both of those questions, as we talked about earlier today, can be answered by the intercepts of the demand function that we get. Right? On the one hand, the Y-intercept over here gives us a measure of what is the price at which we would sell 0 units of our product. Right? So that answers one of those questions. The other, the X-intercept, gives me the situation if I were to charge no money at all for my product, how much of my product could I give away? Right? What's the largest potential size in the national market for my product? And because our demand function is a quadratic function, we have tools of algebra that can help us to answer both of these questions. So I just wanted to put in this plug. Let me write this as P equals D of Q, and D of Q is given by AQ squared plus BQ plus C, where A, B, and C are these parameters that I got out of my regression. So minus 0.00027 Q squared minus 0.148. What did I do here? Let me just do 1.5. Q plus 558. Now, if I wanted to find the y-intercept for this graph, what would I do with this equation? How do I find the y-intercept for a graph if I have an equation for that graph?
Set it to 0.
Set what to 0? If I want the y-intercept, I should be setting the x-coordinate to 0, and here my x-coordinate is q. So if I want the y-intercept, I should put a 0 for q into my equation. And what does it turn out happens to this equation when you plug in a 0 for q? What's going to happen to q squared and to q? Those are both going to be 0. So the only thing that's left standing is that c coefficient. Right? So plugging in a 0 for q gives me the p-intercept. Right? This is going to be my largest possible price that the market can sustain. How about the other side? If I want to know the other intercept, the intercept with my q-axis, what do I have to set to 0?
Y.
Yeah, the y, which in this case is p. Right? So to find out the total quantity that I could possibly give away in the market at any price, I would set p equal to 0. Now, of course, that gives us a different algebra problem. If I set p equal to 0, now how am I going to get this q solved for? What tool from algebra do we have that can help us to solve an equation that looks like this one? You could try to factor this equation. I wouldn't try too hard. All the tools that you learn for how to factor quadratics really work best when the numbers are nice, small, whole numbers. These are kind of nasty decimals. So what's our backup plan?
Quadratic formula.
Yeah, let's use a quadratic formula, right? To get some practice with the quadratic formula. Quadratic formula, know it, love it, live it. There are numerous YouTube videos that can teach you how to memorize it using nifty songs and all kinds of other acronyms and fun stuff. But yeah, this is a place where it actually avails us because it can tell us what values of q make this quadratic expression equal to 0. All we have to do is supply this formula with values for a, b, and c. Those are the coefficients of the quadratic, linear, and constant terms, respectively. So if we stuff those in to this equation, and if we're careful enough in applying the order of operations to evaluating that quantity, that should give me, turns out it'll give me 2 different answers. But one of those 2 answers had better be the q that matches with our intuition from down here, which we said was approximately 1180 something-ish, whatever. But if you want a high precision answer for that, you can use the quadratic formula. So anytime we have an algebraic model for something, right, the intercepts are almost always meaningful. They almost always tell us something that we care to know about the relationship between 2 quantities. We're going to talk a lot more this semester about what other features of an algebraic model can tell us. But for now, when the tools at our disposal are just tools of algebra, intercepts And in the case of quadratic equations, if there's a vertex, like the top of a hill or the bottom of a valley, those are things that we have tools of pre-calculus that we can discover.